Hey guys, Mr. Betts here. Now that we've wrapped up Unit 1, that gives us the foundation that we need to solve those two big problems, the tangent line problem and then later on the area problem. So what we're doing now in Unit 2 is we're going to be moving into the tangent line problem. And to start with, we're going to look at how we can take what we know from pre-calculus and combine it with what we learned in Unit 1 with limits to actually find rates of change and solve that tangent line problem. So first thing I want to talk about here is something called a difference quotient. So what I've got on the screen here should be familiar to you. If we want to find the slope of a line through 2 points, then we have this slope formula right here. And so sometimes we use a notation that looks like this. Remember the deltas, those triangles are Greek letter deltas means change. So a change in y divided by a change in x. That's a notation you want to be familiar with because we're going to use that in calculus a lot. And then a similar notation when we get into actually solving the tangent line problem. But I want to talk about this right here real quick. That expression is what we call a difference quotient. So remember, difference is what we get when we subtract things, and a quotient is what we get when we divide things. Well, this is essentially a quotient of differences. So we call this a difference quotient. This is one that we should be familiar with, but we're going to take this difference quotient that represents the slope of a line, and we're going to look at it from a little bit of a different perspective. So I'm going to take this difference quotient here, and I'm gonna look at a picture here. Remember this right here, this epsilon means that x is in the interval from a to b. So I'm just going to pick along the x-axis an a and a b. And so I want to look at what this difference quotient looks like in terms of a and b rather than in the xy notation like we have here. So remember, the slope is giving us the slope of a line. So what we're looking for here is the slope of the line that goes through those 2 points. And the points, instead of x1, y1, x2, y2, the coordinates of this point are going to be a, f of a, and b, f of b. So all I'm going to do here is I'm going to take the slope formula and I'm going to rewrite it as a difference quotient involving those terms. So the slope here is going to be f of b minus f of a. So that's the difference in the y values. So over here we can notate where the value of the functions are going to be. So we have the difference in the y values divided by the difference in the x values. So I just want to point out that this difference quotient is the same as that difference quotient. I'm just replacing the x and the y values with different variables. Keep in mind that we could do this instead of with a and b, we could actually plug numbers in. So we could say a is 1 and b is 3 and then do the same thing. And if we knew what the function was, if we knew what f of x was, then we could go further and we could do it with that particular function. Okay, now I want to do the same thing, except instead of a and b, I want to use a and a plus h. So the idea here is rather than saying this is a and b, what I'm going to do is I'm going to say this is a. This is going to be kind of a starting point for us. And then we're going to go a distance of h along the x-axis, which means that the second point instead of b is going to be a plus h. So same idea here. The only difference is it should be a comma f of a. It's our first point. And then instead of b here, we have a plus h as the x coordinate, and then f of a plus h is going to be the y coordinate. So to find the slope of the line through those 2 points, it's going to be f of a plus h minus f of a all over a plus h minus a. And you'll notice here that we can cancel a's, and really what we get in the denominator is just h. So this is still a difference quotient, even though we don't have a difference in the denominator. And that difference quotient is equivalent to the difference quotient that we have here, just replacing the b with a plus h. So these two difference quotients are going to be difference quotients that pop up a lot when we're dealing with the tangent line problem. And essentially what they are is just the slope formula. But it's the slope formula with some variables in there. I do want to point out here that instead of b, I used x right there. It's the same thing, but if we put b in there, it would be the same. So I'm replacing the b with x. With the tangent line problem, what we're going to be doing then is we're going to take the slope of the secant line here and talk about how we can change that from a slope of a secant line and change it to the slope of a tangent line. And we're going to use these two difference quotients to do that.